Hello everyone, my name is Jimil Shah and I'm an application development engineer at 3M EMSD, that is called Electronics Materials Solutions Division. I did my PhD in mechanical engineering from the University of Texas at Arlington in Texas, Dallas. So today we are going to talk about two-phase immersion cooling of data centers, mainly the servers with high computational power and GPUs. So the gamers would know you need different types of servers or computers, also graphic cards, and that generates a lot of heat. Similarly, I like taking pictures. So when you take pictures, you upload on Facebook, Instagram, Dropbox, OneDrive, different locations. So when you put that on internet, that goes to a server, right? So there are so many servers in data centers. They do different functions. For example, artificial intelligence, like you have Google Assistant, right? So for that you need deep learning servers, machine learning servers, similarly storage servers for your pictures and your information on Facebook and those kind of things. So when you use those servers, or let's say gamers would use high computing and high GPUs computers, they generate a lot of heat. And we have different means of cooling that server, because if you increase the utilization, it will generate a lot of heat, and that is bad for the health of the server. So let me show you a server first, and then we'll go towards the cooling methods. So here you can see it's a high performance computing server which has 4 CPUs, that is called computer processing units. Those are the brains of the computer. It has hard drives and also the accelerator cards. Here you can put the RAMs and also GPU cards. So basically, when they generate a lot of heat, and when you have a lot of servers in one data center, so let's say for example in Facebook's Springville data center, there are 55,000 of servers, right, for different functions. In that case, they generate a lot of heat. So normally you have fan, even in your computer you have fan on the top of your CPU, right? Similarly, there are different methods of cooling, like air cooling. You can also put the conduit of cold plate and you can flow the fluid out of that and cool it down. But now when the need increases, when the power increases, all other technologies have their own limitations. So at the time you need something unique and extremely highly efficient and based in performance with savings in cost, right? So here we do two-phase immersion cooling. So ultimately we just dunk the whole computer inside the pool of fluid. Be aware, this is not water, this is a dielectric fluid. So because the salt water is conductive, right? So we cannot use water. When you put electrons in water, it will be like short circuit. But this is dielectric, so it is not going to affect to the transmission of data and all the stuff. So it's not going to affect to the health of IT. But this fluid boils at certain temperature, just like your gasoline, it boils at 30 to 35 degrees centigrade. Similarly, this fluid boils at 50 degrees centigrade, and this fluid is called 3M fluorinate fluid. So 3M is famous in making premium fluids which can be used for different applications. Today we are just going to talk about this application. And here you can see this is CPU, and on the top of that CPU we are putting a copper plate just to increase the surface area so that heat dissipation will be faster on the top. So because of the low boiling point of this fluid, as soon as the heat is generating through the CPU, the fluid starts boiling, and we have condenser on the top of the tank. The condenser, we are passing the cold water through the condenser or heat exchanger, which is condensing the vapor down into the liquid form again back to the tank, and the cycle repeats itself. And you can use the same fluid and you can keep doing the cycle. But the best part of this, the temperature is maintained at the boiling temperature of the fluid. So the temperature of the whole system is isothermal, is the same temperature. And that's the beauty of this design, that it has a lot of gains. You don't have different variation in temperature, as well as you can reuse the fluid so that you don't have to pay the cost on the operational efficiency. Now math. So being an engineer, whether it is mechanical engineer, material science engineer, or electrical engineer, or civil engineer, we do deal with math a lot. Like big buzzwords called integrations, derivations, standard deviation, statistics, a lot of stuff. Let me explain you the simple to most complex problems. So for example, as I just mentioned, as soon as you go to the school to do your engineering or science, in the very first year you will have to do drawings. That is called engineering drawings, or you must be aware of CAD designs, right? AutoCAD or ProE or Creo, those kind of softwares. So what you do is you deal with a lot of units, measurements, as well as the geometries. Like you have to deal with triangles, hexagons, octagons, squares, rectangles, a lot of stuff, but in different applications. For example, even in this application, your CPU is square or rectangle. According to that, you need to design your copper plate on the top of that to increase the heat transfer coefficient, right? Similar way, when you do big stuff like car, automobiles, so you deal with very complex geometries. You need to deal with aero modeling shape, right? Aerofoil shape. When you do planes, when you design missiles or something like that, you need to deal with the nose of the missile or the wings of the plane. For example, you have aileron, elevators in the plane, and for the flaps, for the braking, I would say wings, those kind of things, you need to deal with complex calculations, complex geometries. Even in day-to-day life, I would say, let's say for example, here you can see for this particular application, we are measuring a lot of temperatures. So temperature, you are converting from degree centigrade to Fahrenheit, so that's again a calculation. You are measuring the thermal resistance, so you need to deal with different equations called like thermal resistance is what? Temperature difference upon power. So again, now you need to create a lot of Excel sheets. You need to measure the power, you need to measure the temperature, and then you need to divide with power, right? The temperature difference divide by power. So you need to create different Excel sheets to create a lot of graphs, generate different data points. After doing graphs, you take the points, normalize them, and then you analyze the data. So a lot of work in day-to-day like simple life to your complex problems like defense, you deal with math a lot. And frankly speaking, don't ever get bored of math, because math is the most fun part of the study. I know I used to hate math as well, and I also used to get rid of math. But the thing is, as soon as I used to try to run away from math, it used to follow me. So ultimately, I just put my weapons down. I started following math, and then it stopped following me. And now I did my PhD like with the fraction of time, and I'm doing a great in my job, dealing with maths every day, because now math is a part of my life. Thank you.